The last video introduced us to the law of cosines, and now we want to see the law, well, okay, maybe I should spell this right, law of cosines for vectors. So we're going to try to, translate that similar concept over to vectors. So let's go ahead and write two vectors out over here. Do I want to? Yeah, I think I'm going to, treat myself to some straight lines because we did that last video and it worked out pretty nicely. Look at that. Oof, that's fresh. Okay, I fucked up that last little edge there. Okay, that's fresh. That's awesome. I'm always trying to draw it out with the stylus and it just doesn't work. Oof, yeah. Look at that. Fuck, that's sexy. Okay, now, we'll have to go to there. Okay, so we have those set up over here. This will be x, this will be y, and this will be the angle that's between them, theta. So we have these this is in space. We'll just call these are in space Rn, right? So they're in any space right now. And we want to see if we can translate those over to a formula where we'll have the lengths of the vectors and the angle involved, which is essentially what we saw with the law of cosines, right? We wanted to have the three edges of the triangle as well as the angle involved in some type of formula that we can use when the triangle did not contain a right angle. So we want to go ahead and draw this, and essentially how we're going to write this is we'll have this line over here. And this is going to act as like our C, right? This is the C that we had from before is going to be here. And essentially is going to be x minus y. So the length of x minus y squared is going to be that one. And so in this case, b squared is going to be, over here, b squared. Let's go right, b squared. So this is, remember, we're relating back to the last video. So this b squared is length of x squared, and a squared over here is the length of y squared, right? Do I need to write out the cosine triangle again? Let's do it just in case, right? Just in case you're a bit lost of what's going on, I'm relating it to this that we saw in the last video. So I'm treating myself to some straight lines again because I can do it. Look at that, man, that's sexy. Okay, so problem is, I have to scroll down to go to my layers here. Give me a second. Yeah, because I'm doing all this in Photoshop, so I have to go through the layers. Okay, so we have that here, and then we had some height h, we had a, we had b, we had c. This was two right angled triangles. We had the angle theta over here. Is that all we need? Yeah, that was all we need. And we got the formula over here was c squared is equal to a squared plus b squared minus 2ab cos of theta. You can go ahead and check the earlier video in the playlist. I'll put the playlist in the description. Go one video earlier and you'll see how I went and got this formula over here. So we're trying to look at how we can find that with these vectors. So this is, I did the replacements over here, these things over here, which we're going to be replacing the values that we have in here. So what we can do is we can simply just go and plug those values into this formula that we had. So we went and said that c squared was going to be the length of x minus y squared. So we have that right there. That will be equal to what we had was a squared was going to be this, or whatever. It doesn't matter the actual way that I wrote it. So I think I had, what would it have for y squared? I said b squared was x squared. So, you could essentially reverse those, but it doesn't make a difference here. It's going to be the same thing because we're adding them. So the order doesn't really matter. Then we have subtracted by 2. Then we have subtracted by 2. We don't have these squared values here, so we'll just have length of x, length of y, and we'll have the angle of cosine. So we've essentially written it in the exact same way that we had before, right? We wrote it we just replaced those values that we had for those two vectors, and we had an angle between those two vectors, and we essentially replaced it for the triangle. Now we can actually take this a little bit further. I'm going to show you how we do that. Give me a second. Actually, I'm going to end this off here. Don't want to put too much in this video, and we will resume from this exact spot in the next one, where we're going to relate this to the formula for the dot product, and we're going to see if those two cosines are going to be the same, the angles for the cosines. So we're going to see that in the next video.